Hello friends, this video on motion and time part 6 is brought to you by examfear.com. No more fear from exam. Now there are many types of graphs that exist. So as you can see in the picture itself, there are so many different shapes of graphs. Some of the common types of graphs are bar graph, line graph and pie charts. So as you can see on the screen, each of these graphs, they look very much different from each other and all of them have different way of representing the data. So in the previous slide, I took an example of the graph which was actually a bar graph because you see bars like this representing numbers. Similarly, when you look at a pie chart, it is like it is in a circular form where we divide it into segments and each of these sectors, they represent a specific amount of data. So here you can see this is also a pie chart where you have blue, orange, green. So each of these colors, each of these parts, they represent a specific set of numbers. In case of line graph, instead of bars, you have lines like this where the peaks and the troughs, they actually represent numbers again. So these are all various ways of representation. So let us look at the representation using different types of graphs. So we have taken the same example of the favorite fruits of the students of class 7. Let's say, so here you see, this was the graph. This was the bar graph which I had discussed in the previous slide. So in the bar graph, we saw that 50 students like apple, 40 of them like mango, 30 of them like grapes and 20 of them like banana. So the same thing can be represented using a pie chart. So you see here, this is how a pie chart looks like. So here it is the pie chart. So for banana, it is like a smaller section, the red colored section. For grapes, it is a bigger section. For mango, it is even bigger, and for apple, it is maximum because in apple, you have almost 50 people. Similarly, in mango, you have around 40. In grapes, you have around 30, and for banana, you have just 20. Now, the same data can be represented using a line graph as well. So here you see, the entire plot is done in a similar way as bar graph. Instead of the bars, you just plot the points and then you join the points to form a line graph. So this is how a line graph would look like. So that's how we represent the same data using different types of graphs. So in this lesson, we will mostly, now when we talk about the distance time graph, because distance time graph is used to describe motion of an object graphically. So we are going to talk about the distance time graph, and in distance time graph, we will make use of the line graphs. Now, before we get into that, let us try to draw a graph ourselves. So we will take the same example of the car because this would help you to understand the basics of drawing a graph in a better way. So let's say we have a car and this car is traveling and it covers certain distances over the period of time. So let us say this car, so let's say we take time and we take the distance covered in kilometers. Okay, now let us say that this car, it in 5 minutes, okay, now this time is in minutes. So in 5 minutes it covered 2 kilometers. In 10 minutes it covered 4 kilometers. In 20 minutes it covered 8 kilometers, and in 30 minutes it covered 12 kilometers. So this is how, these are the numbers which define the motion of this car. That is how exactly the car is moving. That is defined by these numbers. Now, how best can I represent these numbers using a graph? So, in order to describe the motion of this car, which are the two variable quantities? So, one variable quantity is distance, the other variable quantity is time. So therefore, first of all, I will plot the x-axis and the y-axis. So this is the x-axis and this is the y-axis. So the vertical axis is the y-axis, the horizontal one is the x-axis, and this common point is called the origin. And at origin, the value of x-axis is also 0 and the value of y-axis is also 0. So this point is termed as the origin. So all the distances, all the measurements are done from the origin. Okay, fine. So now we take distance on the y-axis. So we take distance on the y-axis and we take time on the x-axis. So that's how we draw the backbone of a graph. Now the next important thing that we need to do is we need to decide the scale on the x-axis and the y-axis. Okay, so x-axis is all about time, and what are the time that we have? 5 minutes, 10 minutes, 20 minutes, 30 minutes. Okay, now how do we plot them? So let's say now if you actually look at a graph paper, if you have ever drawn a graph on a graph paper, you will see that the graph paper contains squares like this, and inside the big squares you have small squares like this. So that is how a graph paper looks like. So while scaling the x-axis and the y-axis, we assume that okay, one big box would represent these many units. Now why do we do that? I'll tell you about that also. So right now let us say that we assumed that one big box is representing say 5 minutes. So I say this is 5, this is 10, this is 15, this is 20, this is 25, this is 30 and so on. So let us say one big box is 5 units, or one big box represent 5 minutes. So that's how we scaled the x-axis. Now let us try to scale the y-axis. Now in the y-axis we have distance, and here the distance values are 2, 4, 8 and 12 kilometers. Now here I will tell you why do we need to do this kind of scaling on the x and y axis. Now do you think that it is possible to plot a distance of 10 kilometers on a piece of paper? A piece of paper is too small to actually measure 10 kilometers. 10 kilometers is a huge length. So how do we plot it on a piece of paper? So for that purpose we do this scaling. So we assume that, let's say that one big box represents 2 kilometers. So we just assume that. Okay, so one big box is 2 kilometers. So the next one is 4, 6, 8, 10, 12 and so on. So that is how we scale the y-axis. So now that the x and the y-axis have been scaled, now your job has become very easy. So now you just look at these numbers. So in 5 minutes it had traveled 2 kilometers. So 5 minutes, 2 kilometers. So this is the point. In 10 minutes it traveled 4 kilometers. So 10 minutes, 4 kilometers. In 20 minutes it traveled 8 kilometers. So 20 minutes it traveled 8 kilometers, right? And in 30 minutes it traveled 12 kilometers. So somewhere here. So this is 12 kilometers. Now you got these 4 points from the data that is given about the motion of the car. So now when you join all of these points, so when you join all of these points, you get a straight line like this. And this represents the distance time graph for the motion of this car. Now looking at this distance time graph, now since the distance time graph is a straight line which is passing through the origin, it says that it is a motion where the car is covering equal distances, certain distances in equal intervals of time. Now what all can we interpret from distance time graph, that we are going to discuss in the next section. But for now you should know how to plot a distance time graph. So I hope you understood that why do we do these kind of scaling, why do we assume that one big box represents these many units, right? So in this case, if you look at the x-axis, one big box is representing 5 units. Similarly, if you look at the y-axis, one big box is representing 2 units. Right? So that's how we plot or we draw a graph. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.